In this video, we are going to go over how to solve multi-step equations by clearing out fractions. Oh yeah, it's very, very cool stuff. So let's jump right into this. In a previous video, I showed you how you could solve out an equation like this without clearing out fractions. So this is a method that is not necessary, but at the same time is very, very cool if you know how to use it. So how do we do this? Well, basically, we look at the denominators here. We see that there's 3, 4, and 6. And we think to ourselves, what would I need to multiply by so that these 3 denominators would be cleared out? Or what number can I multiply by so that 3, 4, and 6 goes evenly into it? So what we're essentially asking is, what is the least common denominator of 3, 4, and 6? Because if we find the least common denominator, that's the same as finding the least common multiple, which would be a number that all of these go into evenly. So that smallest number that 3, 4, and 6 go into evenly, 12. So I'm going to multiply both sides of the equation by 12. Because if I multiply one side of an equation by 12, of course I've got to multiply the other to keep it true. So I literally just show this work. Different teachers will show it different ways. I'm going to multiply both sides of the equation like this, so I'll put the 12 down here. So I'm multiplying through by 12, and you know what? Let me erase that A, give ourselves some more room right here, and put the 12 right next to it. Beautiful. All right, so we're multiplying through by 12. Now, what's going to happen is I'm going to distribute the 12 to every term. 1, 2, and then here I'm just going to multiply by 12 like normal. So what ends up resulting is we get 12 times negative 2/3. That's the result here. 12 times 3/4, the plus sign stays, got a little distributive property action. And then that's equal to negative 5/6 times 12, which I'm just really copying what I had before. And that's it. You'll get good enough at this, or at least the goal is to get good enough at this, so that you don't have to necessarily show this step and you might be able to do it mentally. It's sweet stuff. Okay, so 12 times negative 2/3. Well, how do we do that? You can put it over 1. 3 goes into 12 4 times. We knew that was going to happen because we picked a number that 3 goes into evenly. So the 12 becomes 4, the 3 becomes 1. 4 times negative 2 is negative 8. Beautiful. Plus 12 times 3/4. Again, you can put the 12 over 1 if it makes you comfortable. 4 goes into itself once and into 12 3 times. That leaves us with 3 times 3 over 1 times 1, or 9. And that variable is just hanging out there. And isn't that beautiful? All the fractions are going away. And so now we're left with negative 5/6 times 12. 6 goes into itself once, into 12 twice. And now we're left with 2 times negative 5, which is negative 10. It's beautiful. The fractions are gone. Now we don't have to deal with them anymore. I think it's pretty rad. Finally, we're just going to solve this like any old two-step equation like you've now grown, I hope, accustomed to rocking. So we're going to undo addition of negative 8 by adding 8 to both sides. We're left now with 9w as the negative 8 and 8 cancel, which is equal to negative 2. And then we want to undo 9 times w. We do that with division of 9. We notice that 9 divided by 9 is 1, so we've gotten w alone, and our final answer is negative 2 over 9. Now, the nasty part is if you do want to check your answer, you would plug it into the original equation with the fractions before you did any alterations and see that it's true. So if you rock this and you're like, yeah, I'm totally good, then great. You can go on, you've gotten what you need to get out of the video. But I've got a second example, just in case you want a little variety. It is an example that we actually went over in a previous video of how to solve multi-step equations with fractions. I thought, let me show you a different way of how to solve this problem by clearing out fractions. So we look at this problem, we notice there's the fractions with denominators 10 and 15. The least common denominator between 10 and 15, the smallest number 10 and 15 go into evenly, is 30. So what we're going to do is we will multiply both sides of the equation by 30. Let me make that parentheses a little thicker. So I multiply this side by 30 and that side by 30. That will clear out our fractions. Beautiful thing. I'm going to now just do exactly what the operations tell me to do, which is use the distributive property. 30 times p is 30p plus, and that will just be 30 times p over 10. And again, some of you might be able to do that mentally. If you can't, that's totally cool. We'll get there. I'm going to do this operation right now. 15 goes into 30 twice, And so we're left with 2 times 2 over 1. And you could have put the 30 over 1 as well if it makes you more comfortable. 2 times 2 is 4 over 1. And now we'll complete the multiplication that's going on the left side of the equation. 30 and 10, well, 30 can go over 1. 10 goes into 30 3 times, into itself once. So we're left with 30p. 3 times p over 1, which is just 3p, equals 4. And yet again, we have ourselves no more fractions. Now notice we've got like terms, so we are going to combine those. 30p plus 3p is equal to 33p. Beautiful. And so now we divide both sides by 33 to isolate p. That's awesome. And note that the 33's divide out, so we're in good shape. And we're left with p equals 4/33, which was the answer to the original problem that we did in the previous video. Clearing out fractions is an alternative method to solving out multi-step equations, or even two-step equations, when you have fractions involved. I think it's particularly great when you have more than one fraction involved. If you just have one fraction involved, try to grin and bear it. All right, peeps, go practice this strategy. I think it's a really cool one to use, and it will come in handy in later math classes.